Hi, everyone. My name is Juan-Roux Van Niekerk. Most know me as JR, and I'll be talking about smart fabrics today. Okay, but before we get into what smart fabrics are, I just wanted to share a fun fact. Smart fabrics actually go by a few names. It goes by electronic textiles, e-textiles, and smart garments. My favorite is smart garments. It sounds pretty fancy. I don't know about you guys. But for consistency's sake, I'll be staying with smart fabrics since, oh, that's what you guys joined for. Okay, let's get into what smart fabrics are. Sorry, it's laggy, I see. Okay, the definition. So smart fabrics are any textile which can like sense an environmental condition and then react to it. So what does that actually mean? Well, let's look at examples, okay? Let's take an example for temperature, okay? My man Xander over there, right? He hates the cold. 20 Celsius degrees below, he hates it. So what does he do? He gets a smart jacket, right? So what that does is it has a sensor, a temperature sensor. Oh, sorry, I clicked. It has a temperature sensor, right? So what it does is it detects any temperature below 20 degrees, and that's the sense. It senses the environmental condition, that's the temperature. Then it reacts by increasing the temperature through like a heating system in the jacket, keeping Xander warm all the time. You'll never have to experience temperatures below 20 degrees again. Okay, our next example, movement, which I kind of spoiled, I'm sorry. If you walk, who goes for runs? Not a lot of you, but okay. Who of you use a smart device to count your steps so that you know how many steps you're taking? A few of you, cool. Now, imagine you have pants on, right? I mean, okay, I hope you have pants on. I mean, running pants. Let's go with running pants. Just imagine a smart running pants, right? It senses you running. It senses you moving, okay? And how that reacts is by counting your steps. Because I mean, what do you believe is going to be a more accurate type of counting your steps? Your watch on your arm or your legs actually moving with your pants? Easy answer. I'm just saying. Some images. Okay, so we know what it is. Let's look at how smart fabrics work. So smart fabrics can achieve the sensing and reacting with a combination of digital components. I'm only going to go through a few. So these are the few. The first one being conductive fibers. I don't know if anybody knows what that is, but that is literally basically the wiring of the whole smart system. So this isn't just your normal like cable. This is a non-conductive, I clicked again, I'm sorry. This is a non-conductive or less conductive substrate, which is coated or embedded with an actual conductive element. That being like silver, gold, copper, if you're fancy gold. Yeah, so this ultimately basically connects all the other components together. So this is not what the entire smart garment is made of. This is purely like for the wiring of the components. I already clicked before, so I'm skipping ahead, I'm sorry. I'm giving you guys a preview. So next we have the sensors. So this, I hope you can guess, senses the environmental condition. We have many types of sensors. We have like gas sensors, temperature sensors, we have like gyrometric gyroscopes, which like sense velocity in each direction. And depending on the type of sensor, it will depend on what type of environmental condition you're going for. We have our, I keep going ahead. Then we have our microcontrollers, right? This is ultimately the brain of the whole system. So this gets like the data from the sensors and it processes it. Then it sends it to the correct device with what should happen. So going back to the example of like the temperature, it receives, okay, it's 20 degrees. It goes like, okay, Xander hates that. Let's activate the heating system in the jacket, keeping him warm and not below cold. Cool. Then finally, you guys already saw it, power source. So this is what will keep everything powered, everything working. Without the power, I mean, it's not really going to work. But this is specifically directed at like batteries and stuff. This is not going to be like something ESCOM can take away from you. So at least you'll be able to use your smart device between 2 and 4, hopefully. But yeah, this is also something most likely to rechargeable. because replacing is not going to be the best. And types of batteries used are most likely flexible batteries, as well as solar cells. Okay, now that we have an idea of what smart fabrics is, I hope, and how it works, we're looking at a few applications, right? The first area I'm looking at is sports and fitness. Smart fabrics in this area can really help athletes excel in their training. Imagine being able to like know how fast you're running accurately, how fast your heart is beating. Everything combined into one vest you're wearing. An example of this would be the Hexoskin. I'm going to show with my mouse. This is like Hexoskin. So this is a real-world example of a smart garment available to the public. So athletes can use this one to track their cardio, their activity, even their sleep. Dedicated ones will actually wear this when they go to bed, knowing, okay, I slept 6 hours. So all this will help them further their training and achieve exercises they didn't know were possible, because they would see the previous one was a bit lacking. So now, if I train a bit like this way, I can improve my overall gain. Next, we have our healthcare. Within healthcare, we can have smart fabrics which give patients their medicine. A real-world example of this one would be the Quell pain relief technology. So what this does, you strap it on wherever you have chronic pain, right? And then it sends electronic signals to your nerves, targeted at like specific nerves to like reduce your pain. So if you have constant leg pain, you just strap it over it, fire it up, and it sends the electrical nerve stimulations, and that would alleviate a bit of your pain. Okay. Then we have like military. We have a lot of uses in military and law enforcement. One would be the enhanced sensory awareness. So having sensors behind your back, like specifically human sensors, so that military will know when there is like an ambush from behind. This is actually just limited at the moment because like human sensors don't reach that far. But if somebody sneaks up on you, you'll get like a notification on the within your suit. Then we just have a couple of miscellaneous uses. First, we have the Jacquard by Google. Google is collaborating with Levi to give you like a smart jacket, which you can basically, sorry, I'm blanking on the word, which you can use to interact with your technology. So with this, you can literally tap on your shoulder or your sleeve and then call somebody. Or you can literally accept any calls by just like flicking your wrist, for example. Everything is to enable you to interact with your technology. Then we have the sound shirt. The sound shirt is a kind of an interesting one because this enables deaf people to hear. Well, kind of hear. This is only available in an orchestra, this specific one. And there you can like purchase like a session, and a deaf person will wear it, and an orchestra will then play music. So this is like a full-on orchestra, multiple instruments and everything. How this works, it has multiple microphones directed at like a type of instruments or areas in the orchestra, and then 18 sensors of vibration, the microphones are the sensors, and then vibrating areas, 18 of them on the suit will vibrate according to the intensity of the instruments. So let's say the violins are playing softly, their shoulder will like softly vibrate. And then you have like the trumpets who are like super intense, and their back are intensing with that. Through this, they can kind of like get the sensation of hearing the actual feeling of like an orchestra. And then lastly, we have our knitted keyboard. This was just something I wanted to add. It's pretty interesting. This is like the instrument keyboard. It's not a computer keyboard. So this is literally a fully knitted keyboard, which you can take anywhere, wear as a scarf, but still function as a fully keyboard. That was just something interesting I wanted to add. But it does sound interesting. It does sound like it has promise, right? But the problem is, it does have a few challenges at the current moment. So it's not mainstream because stuff like durability. Just want to add, this is not applicable to all smart gadget real world examples. This is just like smart fabrics as a whole. So the durability. Smart fabrics need to be able to handle wear and tear. Because I mean, if we're going to wear it every day, it needs to be able to still function at the end of the day. And you also want to be able to wash it. You don't want like to wear this dirty jacket because you can't wash it. Otherwise, oh, there goes like $2,000 for this jacket or something. So that is the first thing that needs to improve before it can actually be mainstream. Then we have, okay, there we go. Power management. But we have battery life. The battery life in smart fabrics depend on the type of batteries you use. Since we're basically limited to flexible batteries, they don't have the best battery life. So they are not, they can't run for too long. They are rechargeable, but that means still you have to wait and recharge it before you can actually fully utilize the functionality of it. Then we have the cost. At the moment, it is very, very expensive to actually make a smart fabric. So even just like a smart jacket is going to be like $200 at the least, I'd say. So getting researching like new materials to lower the cost at the minimum would make it much more possible to have smart fabrics in the mainstream. Then we have connectivity. Since this is a smart device, it sometimes needs to be connected to the internet or at least a device. Without these connections, it will not actually be able to function. Because without any, example, internet access, it will not be able to like send GPS, the signal anywhere, for example. Then we have our user acceptance. This is the big thing where people don't see the need in it. Why do we need a smart jacket when I have a smartwatch? Why do I need any of this? But this is also just opinionated because like smart watches, when it came out, everybody was like, why do you need a smart watch when you can just use a normal watch? But we're at a stage where smart watches do more than just tell time. It's like a mini phone you can utilize without having to struggle to get your phone each time. Although I'm saying all these challenges and everything, there is still future possibilities with this. If that is overcome, smart fabrics will definitely be among our usual wearables that we use. The first possibility is adaptive clothing. So if it's researched further, it can be used to create adaptive clothing. So what does that actually mean? That is a clothing that adapts to the user's environment. Let's say, for example, the temperature thing again. It's super cold. So what it does is it adapts by heating you up. People can hike up mountains much more easily, much more safely, I'd say, because the cold up there is beyond what a human can actually handle with just like a normal jacket. With this, they can stay warm even while at the top of a mount, anything. Then we have another example would also be like the porosity of the clothing, allowing sunlight to go through or not. If it's like a super, the UV index is extreme, even through a jacket, you might burn. So having that detect the UV index is like extreme and lowering the porosity, making the sunlight less able to actually burn your skin will be an amazing possibility. Then we have energy harvesting. So this can be quite a few examples would be like sunlight. If you're walking around the sun all day and you have like solar cell batteries, it'll always be charged fully to either be used as a power bank, even charge your phone, charge your watch, or just power the device itself. So combining this with other smart fabrics would be what keeps the battery life of forever, I'd say even. But there's also kinetic, for example, with the pants. While you're moving, you literally build up electricity to power whatever you want. Then we have our communication. Smart watches at the start were also just smart watches, a screen with which shows you like time. Imagine with clothing, we were able to call like how we're able with smartwatches at the moment. Having like speakers in your collar and a microphone like on the button. You don't even have to reach for your smartwatch anymore. You can just tap your shoulder, start talking to your buddy. Just telling, yo, I'm talking through clothing. How weird is that? But smart fabrics really have a great future, I'd say. If we develop this further, it'll be something revolutionary. So my closing remarks would be, if you're ever interested in actually developing smart fabrics, you want to dabble in it, or you just want to help create something, I'd say go to a website called Adafruit, ADAFRUAUIT. This is a place where you can literally buy sensors or devices for wearables specifically. So it is bendable. You can even buy a conductive thread there, and you can dabble with it yourself. It is an American website company. So I'd say look at distributors here. It will be a bit expensive, but if you want to play around with it or make something, it'll be worth the while. And then lastly, if this even just sounds interesting, looking it up on YouTube would be amazing. You'd see a lot of interesting products that are being worked on right now or already out. But thank you for listening all. I hope you'll also see the future capabilities of smart fabrics.